Hello everyone, let us see the solution of this question which is being displayed on your screen right now. I had posted this question in my last video. Let us first understand the question. The question says that if ABC is an isosceles right angle triangle with AB equal to AC equal to 1, which means AB AC are equal sides, P is any point on this perimeter of the triangle, then we have to find the maximum value of PA into PB into PC. So let us suppose that in case 1, let's suppose that the point P lies on either on the side AB or on the side AC. So suppose that, let's first draw the diagram. Suppose this is triangle ABC and this is the angle, right angle. Now let us suppose that the point P is lying on AB. Here the length of AB and AC both are equal to 1. So it is given that AB AC both are equal to 1, right? So now what you can see that AP plus PB, AP plus PB, as you can see in the diagram, it is equal to AB. Now I am applying arithmetic geometric mean inequality. We can write AP plus PB divided by 2 greater than or equal to geometric mean of AP and PB is AP into PB whole raised to the power 1 by 2. And since AP plus PB is 1, so therefore 1 by 2 greater than or equal to square root of AP into PB. Solving this, we are getting AP into PB less than or equal to 1 by 4. So we can say that the maximum value of AP into PB is equal to 1 by 4, and of course in that case AP and PB both are equal to 1 by 2, right? Now let us join P to C and we are getting PC. So we have to find the value of PC. Now, so we can say that BC is equal to root 2 as AB and AC both are equal to 1, and if we apply the Pythagoras, we are getting BC is equal to root 2. And since PC is less than equal to BC, as you can see in the diagram, PC is always less than equal to BC because BC is the hypotenuse of right angle triangle, so it is always the largest side. So we are getting PC less than equal to BC and BC is root 2, so PC is less than equal to root 2. So now I am multiplying AB into PB into PC. This of course less than equal to, multiplying both inequality, we are getting root 2 by 4, which is equal to 1 by 2 root 2, right? Now you can see that the maximum value of PA into PB into PC, as it seems from here, that should be equal to 1 by root 2. But as in this case, for the maximum value to achieve, we must have corresponding position of P on the side AB. But as we can see that the maximum value in this case cannot be achieved. Why? Because for the maximum value to achieve, we must achieve the maximum in both these inequality 1 also and inequality 2 also. We must achieve the maximum value for some fixed position of point P. But if point P, suppose point P achieves its maximum in inequality 2, in that case point P coincides with the vertex P. But as soon as it coincides with the vertex P, PB is equal to 0, therefore inequality 1 is not satisfied. Therefore both inequality cannot achieve maximum simultaneously, and therefore the whole inequality PA into PB into PC, that it cannot achieve its maximum for any position of point P on the side AB or side AC. Now let us say that the point P lie on the side BC, and I am assuming this as a case 2. Now let us first draw the diagram. As you can see here, I am drawing, this is right angle triangle, and as you can see I am just choosing any point on the side BC. This is side BC, okay? And let us first drop a perpendicular from the vertex A on the side BC, as this is a isosceles triangle. So if we draw a perpendicular from the vertex to the base, the foot of perpendicular, let's say this is M, point M, it bisects the side, it bisects the base BC. In this case BM, as you can see here, BC is equal to root 2 as we know, therefore BM must be equal to root 2 divided by 2, as it is half of BC, which is equal to 1 by root 2. And since M is the midpoint of hypotenuse, therefore AM, BM and MC, all of them equal to the circumradius, which is equal to 1 by root 2, circumradius of triangle ABC. As you know that the circumcenter of the triangle, in right angle triangle, circumcenter is the midpoint of hypotenuse, which is in this case is equal to M, and therefore the distance of M from ABC are equal, and those distances are equal to the circumradius. And therefore if I apply, as you can see here, if I apply Pythagoras in triangle APM, we are getting AP is equal to under root AM square plus PM square. Now let us suppose that BP is equal to X. We can refer the diagram. Let's say this BP is equal to X, right? Therefore CP must be equal to root 2 minus X, because the entire BC is root 2. And therefore we are getting this PM. Now BM is 1 by root 2 and BP is X. So PM is equal to 1 by root 2 minus X. And therefore AP is equal to under root AM. As you can see, AM is equal to 1 by root 2, so 1 by root 2 whole square plus PM. So PM is 1 by root 2 minus X whole square, right? And which, if you solve further, if you rearrange the terms, we are getting AP is equal to square root of 1 minus root 2x and plus x square. So now we got AP, we already know BP, and we have assumed BP equal to x, and then we know PC. So if I multiply all of them together, we are getting PA into PB into PC. Now PA, as we have just calculated, this is equal to, and PB and PC we already know. PB we have assumed x and PC is root 2 minus x, and then I'm multiplying PA, which is equal to under square root of 1 minus root 2 into x plus x square, as you can see just above this line. So if I take x common, we are getting 1 minus x into root 2 minus x. Now we can see that x into root 2 minus x is appearing at two places. So let us suppose that x into root 2 minus x is equal to t, right? Because this is appearing at two places in our expression of PA into PB into PC. In this case, we are getting that PA into PB into PC is equal to t into a square root of 1 minus 2. As you can see, it's very simple. It is very simple. Just substitute x into root 2 minus x equal to t. Now let us suppose we have to find the maximum of this. Okay, notice one thing, that in my original question I have mentioned that f of okay, that is a different thing. So t is equal to x into root 2 minus x, and x into root 2 minus x is geometric mean. So this must be less the square of geometric mean, which must be less than equal to the square of arithmetic mean. So we are getting t less than equal to 1 by 2. Also, you can see that t must be greater than equal to 0, because both x and root 2 minus x are non-negative. So from here we are getting the value of t lying between 0 and 1 by 2. So PA into PB into PC is equal to t into square root of 1 minus 2, where t lies between 0 and 1 by 2. Let us suppose that f of t is equal to PA into PB into PC, which is equal to t into root of 1 minus t, where t lies between 0 and 1 by 2. Now using calculus, can we find the maximum of f of t? Because we have to maximize PA into PB into PC, which means we have to find the maximum value of f of t, right? With the constraint that t lies between 0 and 1 by 2. Okay, so applying second derivative test, let us first find the f test. So if I apply second derivative test, for that we first have to find f dash t, equating it to 0, we will get the value of t, or we can apply the first derivative test also. Okay, so let us first see what is f dash t. So if you differentiate using the product of two functions, we are getting f dash t is equal to square root of 1 minus t, then minus t divided by 2 times square root of 1 minus t. If you take the LCM, we are getting 2 minus 2t minus t divided by 2 times under root 1 minus t. Oh, there is a mistake. Okay, so it should be equal to 2. Yes, so 2 times 1 minus t, right? Now as you can see that t is lying between 0 and 1 by 2, right? So in that case, our f dash t is always positive, because 2 minus 3t, whenever t lies between 0 and 1 by 2 is always positive. You can, if you cannot solve this, then just solve 2 minus 3t greater than equal to 0, and you're getting t must be greater than equal to t must be less than equal to 2 by 3, so which is satisfying. So f dash t is greater than 0 for all t belongs to 0 and 1 by 2. Therefore maximum value of f of t is at x t equal to 1 by 2, and we are getting, in that case, maximum value of f of t is 1 by 2 root 2. So maximum value of PA into PB into PC is 1 by 2 root 2, and the equality occurs, which means that the maximum value is achieved when we have t is equal to 1 by 2. Now we had assumed t as x into root 2 minus x, so we are solving x into root 2 minus x equal to 1 by 2, and then we are multiplying the terms together and rearranging the terms. We are getting 2x square minus 2x plus 1 equal to 0, which is equals to root 2 into x minus 1 whole square equal to 0, which means x is equal to 1 by root 2. Now since BC is root 2, so 1 by root 2 is root 2 by 2, which is BC by 2, and x means BP. As we can see in the diagram above, we had assumed in the beginning itself that this BP is equal to x, right? So since BP is equal to x, which is equal to BC by 2, which means the point P coincides with the midpoint M, and therefore when the point P becomes the midpoint of side BC, we are achieving the maximum value of PA into PB into PC, and that is maximum value is equal to 1 by 2 root 2. So yes, this is still being written on your screen that point P is the midpoint of PC, and in this case we are achieving the maximum value of PA into PB into PC. I hope for all of you the solution is clear, and this question is pretty much similar to the questions which is asked in JEE Advanced these days. I hope that you people have learned considerably from this video. There is too much to learn from this